Hello guys. Welcome back to another video. We have got some latest updates for you. TESS, NASA's next exoplanet hunter. The Transiting Exoplanet Survey Satellite, TESS, is an upcoming NASA mission that will look for planets orbiting the brightest stars in Earth's sky. The mission will monitor at least 200,000 stars for signs of exoplanets, ranging from Earth-sized rocky worlds to huge gas giant planets. TESS is slated to last 2 years, but, if the mission is extended, it may look at more stars. The mission will launch no earlier than April 16 from Cape Canaveral Air Force Station in Florida. Its launch vehicle will be a Falcon 9 rocket from SpaceX. From Earth, TESS will eventually make its way to a special orbit high above the planet, where it can perform observations with minimal interference from Earth's atmosphere. TESS anticipates the discovery of thousands of exoplanets of all sizes around a variety of star types. The Massachusetts Institute of Technology, MIT, which is leading the mission, said in a statement. Along with a network of ground telescopes that will verify TESS observations, the mission will find at least 50 planets that are close to Earth size, no more than 4 times Earth's diameter. TESS is expected to find more than 1,000 planets smaller than Neptune, including dozens that are comparable in size to the Earth, added a team led by TESS principal investigator, George Ricker, who is an MIT astrophysicist. In a 2015 journal article about the mission, public data releases will occur every 4 months, inviting immediate community-wide efforts to study the new planets, he added. The TESS legacy will be a catalog of the nearest and brightest stars hosting transiting planets, which will endure as highly favorable targets for detailed investigations. TESS was first proposed in 2006 as a privately funded mission with financial backing from several institutions, including the Kavli Foundation, Google and donors at the Massachusetts Institute of Technology, according to NASA. It was eventually selected in 2013 as a mission in the Explorer program, which features large craft but do not exceed $200 million. TESS will occupy a never-before-used orbit high above Earth, according to NASA. The elliptical orbit, called P/2, is exactly half of the Moon's orbital period. This means that TESS will orbit Earth every 13.7 days. Its closest point to Earth, 67,000 miles or 108,000 kilometers, is about triple the distance of geosynchronous orbit, where most communications satellites operate. When TESS reaches this point in its orbit, it will transmit data to ground stations. The process will take about 3 hours. Then TESS will pass through the Van Allen radiation belts to the highest point of its orbit, at 232,000 miles, 373,000 kilometers. The solar-powered spacecraft carries 4 100mm wide cameras that provide wide fields of view, according to NASA. They will stare at a particular region of the sky for between 27 and 351 days each, before moving on to another area. The length of time will be decided according to where the region is in the sky, MIT stated. The spacecraft is expected to map the southern hemisphere in its first year, and the northern hemisphere in its second. Hubble captures new image of 2 colliding galaxies. Talk about getting up close and personal. The 2 spiral galaxies that make up the ARP 256 system had just begun a long and chaotic journey together, destined to spend millions of years colliding into each other before finally merging into a galaxy all their own. The image, captured by NASA ESA's Hubble Space Telescope, shows the barred spiral galaxy duo slowly combining in Cetus the Sea Monster, about 350 million light-years from Earth. Their spiral shapes aren't nearly as pronounced as they used to be, as the gravitational forces responsible for drawing the galaxies together cause them to become stretched and distorted. Their nuclei are still far apart and won't be converging anytime soon, but the image shows distinct signs that an exciting galactic collision is underway. The galaxy on the upper left boasts prominent tidal tails, filled with dust, gas, and stars, being pulled toward its companion. The vibrantly blue specks scattered throughout the image are stellar nurseries from which hot new stars are consistently emerging. The uptick in star formation is caused by a surge in interstellar dust and gas motion triggered by the strong gravitational interactions. The pair was named after Halton R, who first catalogued ARP 256 in 1966 in the Atlas of Peculiar Galaxies. The catalog features galaxies at various stages of evolution, including strangely shaped dwarf galaxies, galaxies producing forceful jets, and those interacting, like ARP 256, the Mice galaxies, and the Whirlpool galaxy. The catalog serves as a tool for astronomers looking to understand how spiral and elliptical galaxies change shape over time. Hubble's Advanced Camera for Surveys, ACS, and the Wide Field Camera 3, WFC3, captured the image, and with such a distinct galactic convergence underway, it's pretty much guaranteed that ARP 256 will be closely observed over the course of its exhilarating union by lucky astronomers in the far. Hubble reveals the most detailed exoplanet atmosphere we've seen to date. WASP-39b is classified as a hot Saturn that orbits a star similar to the Sun, 700 light-years from Earth. The combined data from Hubble, Spitzer, and ground-based telescopes make it the most detailed atmosphere we've observed outside our solar system. Dissecting the atmospheric compositions of exoplanets helps us interpret the vast and complex universe we live in, and our own solar system, closer to home. Our findings continually pump the public and science community alike with curious excitement, and with the most comprehensive set of observations ever conducted, exoplanet WASP-39b's atmospheric revelations didn't disappoint. A team of British and American researchers combined new data from NASA ESA's Hubble Space Telescope with previous data from NASA's Spitzer Space Telescope and ESO's Very Large Telescope to create an amazingly detailed atmospheric analysis of exoplanet WASP-39b. The results are the most in-depth analysis of an exoplanet atmosphere possible with available technology. An absence of high-altitude atmospheric clouds gave Hubble a clear view deeper inside WASP-39b, making it the perfect target for observation. The exoplanet sits 700 light-years from Earth and orbits a star similar to the Sun. Because WASP-39b is comparable in mass to Saturn but is much closer to its star than Saturn is to the Sun, it is categorized as a hot Saturn. The name gives away the obvious temperature disparity. WASP-39b is a sweltering 1,382 degrees Fahrenheit 750 degrees Celsius, while Saturn averages -288 degrees Fahrenheit, -142 degrees Celsius. The exoplanet is tidally locked to its Sun, meaning the same side faces its star all the time, but the world's strong winds blast enough heat to its dark side to make both sides equally hot. It was predicted that, like Saturn, WASP-39b would be home to water vapor. The team tested this by analyzing the starlight that passed through the exoplanet's atmosphere. As starlight travels through the atmosphere, it combines with emission from atmospheric atoms and molecules into a single signal. By examining the spectrum and removing the components due to starlight, researchers were able to see the types and amounts of atmospheric gas present. They found that WASP-39b has much more water than expected, about 3 times the amount that Saturn has. The high amount of water implies that at one point, the exoplanet was blasted with large amounts of icy materials that accumulated in its atmosphere. However, this wouldn't have been possible with the scorching temperatures raining down from its host star. The researchers believe that WASP-39b actually formed 8 times farther away from its star than sits now and proceeded to make a significant trek inward over time. The team hopes to conduct a more in-depth analysis of WASP-39b with NASA's James Webb Space Telescope, which is set to launch in 2019 and will be able to detect atmospheric carbon. By calculating the amount of carbon and oxygen in the atmosphere, we can learn even more about where and how this planet formed, said Wakeford. WASP-39b holds the throne for the most finely observed exoplanet atmosphere for now, but with our rate of exploration and ever-advancing technology, it shouldn't get too comfortable. Thank you guys for watching this video. Do like and share this video. And don't forget to click the subscribe button for more such future updates.